Right, this is battery update number 2. This is the material that is being used to contain the battery. It's very flexible. This is dried material, and I want to show how thermal. It's thermal resistant polyurethane. As in, if I try to burn it, let's just try this. It doesn't actually. Oh, I'm melting my glove. Basically, it's a fire retardant material. It's not actually fireproof. It's fire retardant. There's a bit of steam coming off it, but it's not burning. Anyway, this is what we're using to encase the battery, and because it's flexible, it allows the batteries to expand in case when they get warm and things like that. And this is what I mixed it in. This is the container, and as you can see, it peels out easily. So another good thing is to mix it in a polyurethane or plastic container. And here's the voltmeter I'm going to be using, which limits the current. I'll turn that on. It's currently set to limit the current at half an amp, 490 milliamps. So I'm going to put in this meter in the battery box, and it can be adjusted for the volts. And the maximum voltage that this is set to charge the cells to is about 12.2, because I'm using some 3.6 volt cells. Right, this is the get this in focus. This is that in focus? Right, we're using this polyurethane. Actually, I'll read it to you. Polyurethane composite EL171H/BK. It's a flexible material used in electrical circuit management, encapsulation. So it's especially designed for electronic components and things like that. And I've got a full pack I haven't opened yet, which is in here, and it's 1 kilogram. I actually got 3 kilograms of this stuff, because I tell you, it's best to get it from the source. Best to go to Robner Resins and get it from them, because it's a lot cheaper if you buy it in bulk. Buy 3 packs of 1 kilogram, yeah, it's about £42. Whereas if you go on eBay, you're probably looking at £100 or $200, which is a lot of money. So if you're doing something like this, you want to buy the bulk amount, because you need quite a lot. Now let's go over to the battery, which is here. As you can see, it's actually got a lot bigger. It's actually got a lot bigger now. It's actually, I estimate it weighs about 10 kilograms, probably more, because I can barely pick it up. I've got some dummy batteries, because you can't see it now, because most of this, if you look on the top, it's wrapped up in, I've got it sealed up now. There's a lot of that plastic, that black goo is sealing them up. I've got some of the fire blanket wrapped around, so it's difficult to get inside. But if I get these dummy batteries, which are hollow, these are spacers, you can see how many cells. There's actually 9 rows in here now. That's 3, 4, 5, 6, 7, 8, just for the spacing. There's actually 9, and plus there's plastic insulation between each battery layer in there. Oops, it's hard to hold them, but there's actually 9 layers in there, because the last video I did was 8 layers. So you can get an idea. They don't really stay, they collapse these. But anyway, there's 9 layers of 24 cells in each bank. And I think I worked it out 100 and I think it was 113, wasn't it? Or 100. Anyway, if you work it out, 9 times 24. So anyway, I've got my rubber gloves on, because that black gooey stuff is really not good to get on your skin. It's toxic. You need to keep it off your skin. And I've got a special battery monitor which I've put into the battery pack here. Well, you can probably see that if I turn it on. I don't know, is it on? Right, there's a little battery monitor in there, and that's to tell you if it's charged. When I'm working on this battery, all the cells, I'm actually working with it discharged down to about 3 volts per cell, just about there, so there's not a lot of current going to flow if there's an accident. So it's always best to work on the cells when they're mostly discharged, you know, down to about 3 volts per cell, which is about 9 volts. That way you're not going to have a lot of current flowing when you start adding more cells to the pack, and always discharge the cells down to about 9 volts for 6 cells, or 3 volts per cell, so that when you add more cells there's not going to be a lot of current moving from the charged up cells to the lower charged up cells, otherwise you could blow your batteries up, especially when you've got that many cells in parallel. You don't want to blow your batteries. For example, if this pack was fully charged and I put some flat batteries on here, it would probably blow the flat batteries, because there'd be a lot of current. Around about 125, 130 amp hours is in this pack now, so when it's charged fully. So you've got to be really careful. And there's a bank of 12 cells on this side, which is special because they're just for the battery monitor, and it's wired through a fuse. There's a little fuse here, and it's a momentary fuse, so it doesn't blow permanently. It just cuts out if the current exceeds about 2 or 3 amps. It cuts the power off, and it comes back on again when it's cooled down, so that protects that monitoring pack in there. The rest of the cells in this pack are all in parallel, and this is wired in parallel with them through this fuse, so that this can keep monitoring the whole pack and give an average voltage. So there's not really much more except to say that the voltmeter is going to be going in here, and it's going to be mounted vertically, horizontally. It's going to face the front, and anyway, I'll show you that later when we get that sorted out. And all the venting straws come up at one end here. They're going to be I'm going to be using metal, and there's going to be a little metal box going all the way around these. I'm using a bit of plastic there, but there's going to be a metal box going all the way around these, because they're going to be for the vent. And then there's going to be fireproof fiberglass, fire blanket material inside the box to act as a filter and block any exhaust if anything goes wrong, just for safety. But I've got this galvanized steel which I'm going to be using as the metal box, which is going to go on there last, and that's when the top of the battery is finished off. And I think really that's all there is, except for this fuse. I've shown this before, a 30 amp trip fuse, a reset fuse, so it limits the maximum current coming out of here at any one time to 30 amps, so it can't be overloaded. And but that's not a lot when you consider the amount of cells in here is at least about, if you took 1 amp out of each series of 3S, then that would be about 96 amps, I think it was when I worked it out before. So the 30 amp hour trip would be more than adequate to protect the pack from any overloads. So I think that's really all for now. When we get some more updates, I'll let you know. You can stop now.